Welcome back, ladies and gentlemen. This next video tutorial that we're going to do, we're actually going to write a useful program. And in that, we're going to use everything that we've learned previously, plus a new concept of a constant. So I'm going to do what I normally do. I'm going to build the skeleton of the program while Brian talks to you about what a constant is.
Okay, so like we saw before with the variables, where you have a label of a container and you store something in that container, a constant is the same thing. It's just that you'll never be able to change what that value is. So if I say x is a constant 5, it's constantly a 5. It will never change. If you try to change the value of x, it's going to throw you an error. So it kind of protects certain constants that you might use.
Right, and we're going to use a very common constant, and it's going to be pi.
Right.
Yes, one of the greatest numbers that has ever been discovered.
Oh, yeah.
So what I'm going to do now is to define the constant. I'm going to do const space float. So what I'm saying is there's a float data type, and I want it to stay constant. That way, no matter what you do, you can't change this.
Right.
And we're going to call it pi.
Sounds good.
And we're going to designate that to be 3.14.
Maybe
159?
926.
926.
Why not?
Okay, so now that we've defined pi, and we've gone over the concept of what a constant is, let's write a program that's going to use this.
Alright, well, let's just kind of demonstrate the fact that this can't change. So let's now on the next line say pi equals 5. And let's try to compile that.
F9. Let's try to save the file first.
Alright, so we'll call this we'll call this constant.
Well, we're going to actually make this new program. We'll call it circumference, because we're going to calculate the circumference of a circle.
Maybe just CIRC?
CIRC. .cpp. Lots of C's in there.
Yeah.
C. Oh, no!
No, I guess we can't store anything as it.
It's a read-only variable. So you cannot change this no matter what you do.
Right.
That's good stuff.
So now we want to define a couple other variables that we're going to use. The first one that we're going to use is the radius.
R.
Sure.
Int R. We're going to use an integer or float?
Int's fine.
Equals
0.
0.
Okay, so then the other one we're going to use is the circumference. So this one we'll keep as a float.
Equals 0?
Yep.
Alright.
Okay. So now once we get into it, let's say, what do you want the radius to be? Let's say we want to define the radius as 5.
Okay, so we will do R equals 5? R equals 5.
So now we're going to define the circumference of the circle. So circumference is equal to 2 times the radius, which is equal to the diameter, times pi.
Alright, so what this is going to do, it's a simple mathematical formula. We're multiplying R, which was 5, which was, initialized here. Multiplying that by 2, and then multiplying that by our constant pi. So now we can do a cout, CIR, ENDL, and this should do the math for us and output the result. So we'll do F9. Bling bling.
There we go.
Absolutely gorgeous.
Yeah.
So this is a simple little useful program you can use to calculate the circumference of a circle.
Right. And so now by this point you're using variables, you're using constants, you're using basic operators.
Changing the value.
Changing the value, data types.
Basic mathematics.
And output.
To the screen.
Yeah.
And pausing the screen.
Yeah. And compiling a program.
So you have now learned the basics, very basics of C++. These are the things that are really important to know, because as the syntax gets more complex, you're going to need to resort back to these things in order to maintain sanity of your long, obnoxious programs.
Right. So while we're on the topic of constants, another useful bit of information about constants is the way you can use the include statements to define a constant. Yeah,
and this is actually pretty neat because you don't really have to designate any kind of data type. It's basically, we're going to define something, store it into a variable, and it pretty much just grabs a line of code. And I think
and puts it somewhere else.
Right. That was kind of a confusing way to describe it, but once you see it, it's going to knock your socks off. It's pretty nice.
So let's say we want to...
why don't we do this? Let's store cout hello into a variable.
That works.
Now this is really neat, and this is going to come in handy when you're doing a lot of extensive programming, and a lot of higher end programs use this technique. So we can do something silly like this. Define, After define, I'm going to write down the name of the variable I want to store it in. So I'm going to write hello, hello-y, hello. Now, here's the cool thing. I don't even have to type an equal sign.
Right.
So everything after hello is going to be stored in hello. So watch this. Cout hello \n for n line. That'll be that.
So basically what this is doing is we're not taking up any more memory to do this.
Right.
We're pretty much just kind of putting a marker. So whenever we use the hello, word, it's just going to kind of jump back to this marker, get this line, put it in with the rest of the code.
Right. So it's a way of defining a constant without actually taking up more memory.
Right.
It's incredibly useful. Here, watch this. It's almost like we're defining our own command. So all we have to do is type hello semicolon, and what's going to happen is when the compiler gets to this, it's going to grab this and it's going to put that right there.
Right.
So watch this. Press F9. It's going to say hello.
Right. Now, since it's just kind of grabbing that line, we could even use this for like a number. So we're not actually saying that this number is this variable name. We're just saying, if we type this in here, just grab this line, and that line could be a number.
Right. And also to further illustrate this point, let's put hello on a couple of lines. So we're doing hello, hello, hello.
Yeah.
Press F9. Ka-chunk.
Hello, hello, hello.
Right. It's the equivalent of typing cout hello on each one of these lines.
Right.
So it's a really, really neat thing. And like when you get into doing more complex loops and things, it's really nice to simplify your code down to just one word. So that is the simple usage of the define, and we'll just continue on from here.